Now we'll do today class 11th surface tension. One of the important concept in which you see the daily life applications, जैसे रेन ड्रॉप्स spherical होती है, या whenever we put a brush in the water, it sticks together, but spreads from each other, and when we take out from the water, they stick together. तो ये सारी चीजें सरफेस टेंशन के बेसिस पे हम एक्सप्लेन करते हैं. तो ये क्या है और बेसिक्स क्या है? लेट अस सी. When we talk about this surface tension, then one line definition would be that the property of a liquid due to which it behaves like a stretched membrane so as to minimize its surface area. Now, तो सरफेस एरिया को जो कम करने की टेंडेंसी है, तो कैसे कम होएगी? जब स्ट्रेच मेम्ब्रेन जैसा बिहेव करेगी. तो ये सरफेस टेंशन के कारण से होती है. सो फार मेजरमेंट इज कंसर्न, तो कहते हैं कि सरफेस टेंशन बिकॉज किसी ओपन सरफेस पे होती है, जैसे कोई कंटेनर है और यहाँ तक इट इज फिल्ड विथ वाटर, तो सरफेस टेंशन विल एक्ट ऑन इट्स सरफेस only which is in touch with air. So surface tension per unit length of this surface is measured. So force per unit length is the measurement of the surface tension. Now, so accordingly, what could be the unit? Obviously, unit हो जाएगी न्यूटन पर मीटर. Then surface energy. When it comes to surface energy, it means work done per unit area of a liquid surface. This we explain with the help of a rectangular frame-like structure. And in the rectangular frame-like structure, we have a movable part. Let's say this PQ part is movable, having some surface area, let's say A. Now इसको हम immerse करते हैं soap solution या liquid solution, detergent solution. And when we take it out from that, force of surface tension would be acting on the both the faces. Now if you apply some force, then we shift it, move it by distance dx. So let's say this is P dash and Q dash. So how much work is done? The work done basically is force multiplied by displacement. Now this force will calculate in terms of surface tension. Surface tension की symbol sigma use करते हैं, which is force by length. So force would be sigma multiplied by length. So we write work done as sigma into length into dx, but we multiply it by 2 times. So how much is the increase in area? When we talk about increase in area is length into breadth. Length is L and breadth is dx, but we take 2 type because force of surface tension effective on both the sides. So if you try to find surface energy, it is W by A, which is 2 sigma L dx divided by 2 L dx. So we are left with sigma only. So surface energy is equivalent to the surface tension. Now in this, we'll be doing very significant concept, which is called excess pressure. So when we talk about excess pressure, what is this and how to find the formula for this? Let us have excess pressure inside a liquid drop, right? Let's say this is a liquid drop of certain radius r. Now, due to its internal pressure, let's assume its size increases by certain amount dr. So, if we talk about the work done, then work done basically we write force into displacement. Force over here in terms of pressure. So pressure into area into dr. Pressure is pressure and surface area can be 4 pi r square dr. Then how much is increase in area? Increase in area will be 4 pi r plus dr whole square minus 4 pi r square. If we solve, what we get? It will be 4 pi r square plus 4 pi dr square plus 4 to the 8 pi r dr minus 4 pi r square, which means 4 pi square gone, and square of smaller quantity is neglected. So we are left with 8 pi r dr. Now we have already done the work done per unit surface area is surface energy. So the work done is also surface tension multiplied by increase in area. So this is surface tension sigma and increase in area is 8 pi r dr. So from equation 1 and 2, P into 4 pi r square dr is equal to sigma into 8 pi r dr, which means dr gone, 4 pi and 8 pi, so 2 square and r gone. So we are left with P r is equal to 2 sigma. Therefore, P is equal to 2 sigma divided by r. This is the formula for the excess pressure inside a liquid drop. If we talk about a soap bubble, in case of soap bubble, if we try to find this excess pressure, so everything would be same, but only one step would be different. What is that? When we'll be writing the work done, which is surface tension into increase in area, here we'll multiply by 2, by a factor of 2, because in case of liquid drop, outside and inside, both sides there is air. So surface tension is effective on both the sides. So in this case, P would be 4 sigma upon R, right? What is noticeable is the excess pressure is inversely proportional to R. So smaller is the size of bubble, more would be the pressure, and vice versa. Thank you so much.